Hey viewers, good day. Hope you are doing well. In this video, I will be presenting a brand new concept called solar powered wheat reaper, as you can see in the screen. So let's begin this week. And one more thing, in the previous week we have discussed about the gear train design. Hope you had watched that video, and if you haven't, then please go and check the video. And if you like and do you have any query for me, then please give in the comment section. So let's begin this week. Here project title is solar powered wheat reaper, walk behind. Yes, it is a walk behind, and objective will be design and develop a compact solar powered wheat reaper suitable for small scale farming and student demonstration projects. So this is the main line. This is the main objective of doing all these videos. I want to do it for demonstration projects for college students. Next purpose is, what is the purpose? And purpose will be reduce manual harvesting effort, provide eco-friendly cutting solution, create a CAD based engineering learning project. And deliverables are full CAD assembly plus drawing, motion simulation, bill of material, prototyping, fabrication plan. Yes, this is also in my plan, not optional. And video documentation for educational content. This is also the main plan. And next is the project scope. What is the scope? What's included in this project? As I will be doing the videos in the upcoming weeks, what are the different things that has been included and excluded? First is major design in CAD. This is the major inclusion. I will be showing you all the CAD power system sizing. These calculations I will be showing you. Power system sizing that I will be show you how I have sized the power system, and drive mechanism selection, how I have selected the drive mechanism, safety guard system, and motion study and visualization. See, one or two of these steps I have already done, and which I will be showing you in today's video, that on the SolidWorks interface, what I have done this week. Okay, now exclusions. What's excluded from this project? Full field scale agriculture machine has been excluded, autonomous navigation and mass production manufacturing tooling. This is not the scope. Next is, what is the system level? In this I have broken down the project in the systems. A is mechanical subsystems. These are 6 subsystems that are being under consideration. First is the frame oblique chassis, weldment or sheet metal. It can be of a mix of these two technologies, weldment and sheet metal. Second number is sickle bar cutting mechanism. Third is crank slider motion conversion. And fourth is the feeding wheel. Feeding wheel is nothing but the conveyor system, how the reaper will be conveying this in the cut crop. Next is wheel and height adjustment system. This wheel and height, wheel is star wheel. Star wheel is a component that is being used to convey the cut crop. I will be showing in the next in this video what are the different components that I have already worked upon. Next is the mounting for battery and electronics. This concludes the mechanical subsystem part. Now coming to the electrical subsystems. Here 48 volt battery system. I will be using 48 volt battery system because one primary reason is I want to minimize the number of batteries. So I have selected the higher voltage, that is 48 volt, and solar charging via MPPT, BLDC motor plus controller, emergency stop switch, indicators, SOC charging and status. So these will be including the electrical subsystem. This is just an overview, and some more systems may be added here. Later I will be showing you as the project develops. Safety system. So here blade guard housing, insulation and wiring protection, fusion circuit protection. This is the part of safety system. Design assumptions. What I have assumed here is cutting width is 1 meter. That's not scalable. That I will be working only on 1 meter of cutting width. And blade type will be reciprocating sickle bar. Cutting stroke frequency is 300 to 600 cycles per minute. Motor power will be in this range, 1.5 to 2 kilowatt. That is not the final. As the project progresses, I will be showing you what are the different type of motors that I will be using. I will be using mainly 3 to 4 motors, and where these motors will be used I will be showing in the upcoming videos. Stay tuned for that. And one more thing, if you are liking my content, then please subscribe to my channel. And if you have any queries or want to discuss something, then please connect me over my email ID that I will be giving in the description. So here is the CAD workflow plan. Week 1, concept and reference. Research similar machines, define dimensions and constraints. This steps already done. Now let me mark green. Frame modeling, weldment creation. Week 2, counting points. And week 3 is the sickle bar mechanism. That step I have already done. These 2 steps I have done, and I will be showing in this video in the end what I have done in these 2 steps. And 4 week is reel plus drivetrain. Reel is nothing but the crop conveying system. Drivetrain is the main drive motor that will drive the whole vehicle. Assembly and simulation, that's nothing but the final mates and motion animation that I will be showing you how the final machine will be running. In week 6 I will be showing some technical documentation. That is not necessary to show. Okay. Next is the rough bill of material. Here is BLDC motor 2 kilowatt, battery pack system 48 volt, range is 100 to 120 H, lithium polymer, maybe lead acid because lead acid is also cheaper, and solar panel 200 to 400 watts optional. MPPT controller 48 volt 40 amperes, sickle bar 1 meter, reciprocating already discussed. Frame MS tube 4043, and wheel system, that is conveyor system, shaft arms and tines, drive system, sprocket chain and bearings, wheels 2 pneumatic wheels. I am planning for a 3-wheel drive system. 2 in the front and 1 in the rear. Rear one will be the drive. Testing and validation, dry run, motion test without blade, cutting test, load measurement, runtime evaluation, safety. So all this will be the testing and validation system. Next is risk management. What may be the risks? So these steps starting from 7 and 8 will be tested on the actual prototype, so that will be done in the later. Risk management, excessive motor load. What is the mitigation? Adjust gear ratio, sharp blade. Blade failure, use hardened steel, regular inspection. Battery overheating, mitigation is ventilation plus fuse plus BMS. Vibration issues, add damping and reinforcement. So this is the in the prototyping stage, these two steps. Next, let me show you the deliverable checklist, what I will be delivering in the upcoming videos. Final CAD motion study video, 2D drawings plus flat patterns, BOM with quantities and material, power system schematic, safety compliant notes, project presentation PDF. All this I will be showing you in the upcoming videos. So that's it in this presentation. Now let me show you my SolidWorks window that I have done in this past week for you. Here is what I have done in the past 2 weeks. Here I have worked on the sickle bar, cutting bar system, and decided the motor, decided the sprocket system, crank I have designed today. This is sprockets, and this sprocket will be mounted on this shaft. This shaft will be fixed to the chassis. From here power will be transmitted through a crank. Crank is fitted on this disc, and this disc will be fitted on this sprocket system through bolts. Power will be transmitted through the connecting rod to this bracket, and same pin which is here is being here, same system. This is the welded bracket. The pin will be welded here. This is a simple sheet metal bracket of 2 mm in thickness, and here is the blades. So these blades are mounted with the help of M6 rivets on the sickle bar back plate, which is 30 mm in width and 5 mm in height and 1000 mm long. And this is the supporting bar which is supporting the thrust of the moving sickle bar, and this is the guide fingers which guide the rope. And here in this face, in this edge, and between this edge happens the cutting action of the crow. So here is the work of my previous 2 weeks. I hope you are liking this type of content, and if you have any queries, then please let me know in the comment section so that I get motivated. And one more thing guys, please subscribe. If you like my content, then please subscribe. And if you want to ask something related to engineering or anything, any doubt you have, then please connect me in the on the mail ID I will provide in the description. And once again guys, please subscribe to my channel so that I can get motivated and make some more videos for you. That's it in this video. See you in the next video. Bye bye.